Hello guys, welcome back to my channel Mansa Chemistry. In this video we discuss about the water. I am going to describe this topic on a very high demand by my students. So let's start the chapter. In this video we learn about the water, properties of water, physical properties of water, and last one is water is a universal solvent. Why water is a universal solvent? These all concepts are studied in this video. Now let's come to the next slide. As we know, water is the most precious resource on the earth and it is necessary for all the living beings because we can't live without water. We use water for drinking, for cooking the food, and washing our clothes. In fact, 70% of the earth is covered by water and only 2.5% of water is usable for us. Due to 70% covered by water, the earth look blue. The earth look blue in the images. In fact, 70% of our body weight is water. Now, he is Henry Cavendish, who discovered the composition of water. He told everyone the molecular formula of water is H2O. In water, here are two molecules of hydrogen and one oxygen, and its tell the molecular weight of water is 18 AMU. The chemical name of water is dihydrogen oxide and the molecular mass of water is 18 AMU. AMU stand for atomic mass unit. Now we learn to calculate the molecular weight of water. Here two molecules of water and one oxygen is present. So the atomic mass of hydrogen is 1 and here two molecules are present, then we multiplied by 2 and adding 1 oxygen molecular mass, that is 16. So total molecular weight is 18 AMU. AMU stand for atomic mass unit. Structure of water. In water molecule, here two molecule of hydrogen and one is oxygen. The atomic number of hydrogen is 1 and the electronic configuration is 1. And atomic number of oxygen is 8 and the electronic configuration is 2,8. Hydrogen has one valence electron in its outermost shell and here is 6. So the oxygen has 6 valence electrons in its outermost shell and these oxygen want to complete its octet and hydrogen want to complete its duplet. So oxygen have 6 valence electron and hydrogen has 1 valence electron. To complete the hydrogen its duplet, it make a bond with oxygen electron. This bond is made by sharing of electron, that is shared by one is hydrogen and other electron is shared by oxygen. This bond is formed by sharing of electron. This bond is called covalent bond. This bond is called covalent bond. And the structure of water is like that. They have two lone pairs of electron and two hydrogen atom bonded by covalent bond. Physical states of water are ice, water and water vapors. Water are present in these three states on the Earth. Now the physical properties. First is nature. As we know, water looks transparent, colorless, and it is also tasteless. Next is boiling point. At a temperature when the bubbles start to occur in water, this point is boiling point. Water boiled at 100 degrees Celsius. Different liquids have different boiling point, but water boil at 100 degrees Celsius. Now the effect of the pressure on the boiling point. Let us see. Effect of pressure at the room temperature 27 degrees Celsius. The water has bonding like this, and when we heat this, the boiling point of water is 100. The boiling point of water is 100. But when we increase the pressure, if we increase the pressure, the molecules get closer. The molecule get closer like that. If molecule get closer, now they have strong bonding and need more heat and more temperature to break it. So the boiling point is also increase if the pressure is increase. If pressure is decrease, then boiling point is decrease. That's why at the hill the pressure cooker is used for cooking the food. Next is freezing point. At a temperature when a liquid starts to freeze, this point is called freezing point. The freezing point of water is basically 0 degree Celsius, but if we increase the pressure, the freezing point will be decreased. Effect of pressure on the freezing point. This is the water molecule arrangement at the room temperature, but when we apply the pressure on it, the water molecule get contract. The water molecule get contract, and they need less energy to freeze. So we conclude when we increase the pressure, the freezing point should be decreased. At the 4 degrees Celsius, the water has maximum density because here volume is minimum. Look at the graph. Here temperature is 10 degrees Celsius, then the density is less. Similarly, when the temperature is 7 degrees Celsius, the density is greater than 10 degrees Celsius. But at the 4 degrees Celsius, the density has maximum, and below the 4 degrees Celsius, 2, 3 and 1 degree Celsius, the density of the water again decrease. This means this show the water has maximum density at 4 degree Celsius. When water is cooled, it contract, but below 4 degrees Celsius, it start expand. This can be understood by a example. Anomalous expansion. Anomalous means unusual expansion of water. For example, this is the water molecule at room temperature. This is 27 degrees Celsius. When we cool this water, that means temperature is reduced. When temperature is reduced, the water molecule get contract. The water molecule get contract and come to the closer. But this contraction is only occur at only 4 degrees Celsius. Before 4 degrees Celsius, if we cool this liquid, then expansion is occur. Then expansion is occur at the 0 degree Celsius, and 0 degree Celsius is the freezing point of the water. When we again it cool, it change its phase. It changes phase. This water is converted now solid ice cube. The temperature is also now 0 degrees Celsius. In this only phase change, but the temperature remain same. Latent heat of fusion, the amount of heat energy required to change 1 kg of solid into liquid. Required heat energy does not change temperature, just required heat energy. Let us see here one ice cube that is 1 kg solid and converted into liquid at the 0 degrees Celsius, but it requires only heat. This heat absorbed by the solid molecules and rise his kinetic energy and rise its kinetic energy to convert solid into liquid. Latent heat of vaporization, heat energy required to change 1 kg of liquid into the gaseous or the vapors at the atmospheric pressure. Heat energy. Heat energy. I'm again says heat energy. We do not require to raise and change the temperature. Here, water at 100 degrees Celsius, it's a boiling point of the water. When this liquid convert into the gaseous or the vapors, the temperature is same. The temperature is same, but we apply the heat. This heat absorb the water molecule to increase the kinetic energy to convert the liquid into vapors. Remember one thing, temperature same but heat different in two phases. In these two phases, heat is different. This is the hidden heat that converts the liquid into the solid. This hidden heat is called the latent heat. Specific means particular value, a particular value. For example, when we heat the 1 gram of a water through 1 degree Celsius, you always absorb 4.2 joule of heat. You always give 4.2 joule of heat. This is why it is called specific heat capacity. Next is water is called the universal solvent because it dissolves more substance than the other liquid. They dissolve solid, as example sugar dissolved in water as liquid, milk and water, and it also dissolves some gases in it. That's why it is called the universal solvent. Thanks guys. Have a nice day. Thanks for watching and please like and subscribe my channel. That's Amansa Chemistry.